Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our second class in week 4 of classes in Term 1B. So after this week, we have 2 more weeks of classes before the Christmas break. So as I've mentioned before, please try to finish up your key questions and send them out to me for marking as much as you can before Christmas so that when we come back after Christmas, you're ready to pick up from where we left off. 2 ways to participate in classes, radio or Zoom, and the instructions for joining the classes are in your study guide, or if you don't have a study guide, you can contact your DEC or me for help in joining classes. All PLAR math students are welcome to attend classes, so if you signed up for IL or radio Zoom, doesn't matter which way you signed up, all students are welcome to attend classes. We do a tutorial, so cover the same material, but in a slightly different way with extra examples. To contact me, you can use email, phone, or send a message on Facebook, whatever works better for you. The PLAR English classes from last term, the recordings from last term are available on YouTube. And the PLAR math classes will be updated as I record new classes. So there's 2 places to find the classes. So my B. Osmond WASA, you can go there and you will find my playlist for the PLAR Math and the PLAR English. And then you can also use the WASA Distance Education Center YouTube channel, and my math classes and English classes are there as well. So after this term, once I have at least one version of the PLAR Math and English, I won't be recording to my own YouTube channel anymore. It'll just go to the WASA Distance Education Center channel. So keep that in mind if you're looking for the classes. I will still post a link to the classes on my Facebook page. Okay, so an important announcement for students who did not finish in Term 1A. So if you were doing the PLAR English or the PLAR History Geography in Term 1A, you can continue working on the key questions in Term 1B. So you don't have to, you're not withdrawn at the end of the term. You just sign up at the beginning of the school year or whenever you sign up, and then you just keep going until the school year is done. So you don't have to reapply throughout the school year. That's for PLAR students. And this year we're doing something new with PLAR. So all PLAR students have the option of writing the culminating activity instead of doing the lessons and key questions. So the culminating activity is the test that you do at the end once you've done the lessons. So this year, because we thought about it, and a lot of our students already have older students, you've gained a lot of knowledge already, so you're allowed to challenge the PLAR and do the culminating activities instead of doing all the lessons and key questions. And you can do that even if you have already submitted some of the key questions. So if you started last year or in a previous year and you've done some work, you don't have to finish it. You can do the culminating activity and just try the culminating activity. If you pass it, then you get your credits that you need. If you don't pass it, then you will have to do the lessons and the key questions, and then you can write the culminating activity after that. So you get more than one chance to write the culminating activity. So don't give up if you're not successful the first time. Okay, in your lessons, if you're doing the lessons, and again, that's your choice. If you want to do the lessons, you can do the lessons, especially for someone who's been out of school for a while. You might decide that doing the questions, doing the lessons, and reading material and doing the key questions might be more beneficial for you than just doing the test. So the support questions are there. So there are 2 types of questions in your lesson. The support questions are scattered throughout the lesson. So you read a section, there's a question. Read another section, there's another question, etc. The key questions are all at the end of the lesson. So they're kind of stapled to the end of the lesson, and then you can just pull the key questions off, because the key questions are the ones that you send to me for marking. So they're all located at the end of the lesson. So the support questions are there for you to practice before you try the key questions. So the support questions are basically the same as the key questions. So if you do the support questions and you get most or all of the questions right, then you know you'll do well on the key questions. So you move on to the key questions. If you're struggling with the support questions, once you check your answers, then you know you need to do more work. So their answers to the support questions are there at the end of the lesson, right before the key questions. So just leaf through and you will find a page that looks like this: answers to support questions, and then support question 1, 2, 3, they're all there. Check your answers against those answers, and like I said, if you're doing really well with the support questions, then you move on to the key questions. The key questions are the ones that have marks beside them, and those are the questions that you send out to me for marking. Only the key questions. Okay, so to submit your work, there are several different ways. Of course, the first way is to give it to your DEC, and then your DEC will send it to us here in Sioux Lookout. If your DEC is away, your learning center is closed, or you don't have a learning center in your community, then you can submit your own work. There are different ways of doing that. The first way, if you have access to a scanner, you can scan and email your own work to studentwork@nnec.on.ca. Make sure you get that email correct or we won't get it. And then you can also CC it to me, and my email is on the cover page of each lesson as well as the study guide. Or if you have access to a fax machine at your place of work or at the school or the band office that you can fax it to our toll-free number. And remember, if you are submitting your own work, make sure to write your name, subject, and the teacher's name on your work. Also, putting the community helps as well. So the most important thing, though, is your name. Make sure that is on your work. Otherwise, we don't know who submitted it and we don't know who to return it to. Okay, if you don't have access to a scanner or a fax machine, then you can use your smartphone. So with your smartphone, you can either take photos of your work or you can scan your work, and then you can email it to that same email address, studentwork@nnec.on.ca, and of course make sure you CC it to me, or you can send it by Facebook Messenger. Okay, so whatever works better for you. If you are in Sioux Lookout, or you live somewhere near Sioux Lookout and you come to town often, then you can use our outdoor mailbox, which is located at the side of the building in the WASA parking lot, right beside the door, or you can knock on our front door and someone can take your work from you. You can also use Google Docs, complete your work using Google Docs and then send me the link. Okay, so share the link with me and then I can open your work that way. Again, make sure you put your name on your work. Doesn't matter how you send it, make sure you put your name on it. And then the last way is to use Google Classroom. So just use Google Classroom. You can call, email, or message me for the link and the codes. So lots of ways to submit your work. Don't feel like you can't do it because there's no way to get it to us. You can. Okay, and before we pick up where we left off, a little bit about prizes. So at the end of every term, WASA has 2 student draws. One is for students who earned a credit, and one is for students who submitted work. So if you're submitting your lessons, then your name, for every lesson you submit, your name gets entered into a draw that will happen at the end of the term. If you also earn a credit during that term, your name will be entered into a second draw. So you could potentially win 2 prizes at the end of the term. But you just have to make sure that you do your work and you submit it. Also, before Christmas, students who have already registered with us here at WASA will have the opportunity to win the Community Student Learning Center draw, which will take place on December 16th. So one student from each community, not one student, but one student from each community, can win a $200 holiday gift from a local store. So we will give the money to the store, and then you go in, or we'll give you a gift card, whatever, and then you go in and you can buy, stuff for Christmas or whatever you need. So you have that opportunity to win a $200 holiday gift card. So that draw will be on December 16th, and as I said, that's for students who have already registered with us. All right, so let's finish up with fractions. So actually on Tuesday, we finished the last bit about fractions, and today we're moving on to lesson 2. But before we do that, we're just going to do a review of what we covered on Tuesday. So the last thing that we looked at for fractions is multiplying and dividing fractions. So find the product of 6/12 and 2/10. Now, there are a few different ways of doing this. So the first method is just to multiply the numerators and multiply the denominators and then reduce. So 6/12 times 2/10. So if we multiply our numerators, we have 6 times 2, and we multiply our denominators, 12 times 10. Okay, so for multiplying and dividing fractions, you do not have to have a common denominator. So we've got first fraction, we've got twelfths, the second one we've got tenths. It doesn't matter. We don't have to find a common denominator, okay, because we're multiplying. So 6 times 2 is 12, 12 times 10 is 120. So now we've found our answer, we've multiplied, but we have to reduce. So 12 120ths. So I know that both of these numbers are divisible by 12. So I'm going to divide numerator and denominator by the same number to reduce. 12 divided by 12 is 1. 120 divided by 12 is 10. So my answer is 1/10. Okay. The second method to do this is to reduce first. So what we can do, 6/12 times 2/10 is see if we can reduce our fractions. So I know 6/12 will reduce. Both are divisible by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. 2/10 I know both are divisible by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. So now I have a half times 1/5. So it's easier. 1 times 1 is 1. 5 times 2 is 10. And it's already reduced to lowest terms, okay, because I reduced first. So my answer is 1/10. And it's easier for me to multiply because I'm working with smaller numbers. Method 3, another method of reducing first, is to cross-reduce. So if I can't reduce either one of these fractions, then I can see if I can cross-reduce. Cross-reducing means that I reduce the numerator of the first fraction with the denominator of the second fraction, and the denominator of the first fraction with the numerator of the second fraction. So I can do it that way as well. So 6 and 10, 6 is divisible by 2, and 10 is divisible by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. Now my 12 and 2, 2 is divisible by 2, and 12 is also divisible by 2. 12 divided by 2 is 6, 2 divided by 2 is 1, so now I've got 3 6 times 1/5, and I multiply. 3 times 1 is 3, 6 times 5 is 30, and I still have to reduce here. 3 divides by 3, and so does 30, which will give me 1/10. Okay, so if you can, it's best to reduce first, because then when you multiply, you're multiplying smaller numbers. But if you can't reduce, because sometimes you can't, they're prime numbers and they can't be reduced, so then you just have to multiply and then see if you can reduce after. But always check to see if you can reduce first. Okay. When we're multiplying mixed fractions, like 3 1/7 times 2 8/9, the first thing we have to do is change them to improper fractions. So 3 times 7 is 21, plus 1 is 22/7 times 2 times 9 is 18, plus 8 is 26/9. Okay, so we get 22 sevenths times 26 ninths. Now, we can look and see if we can reduce. 22 is divisible by 2 and 11. And 7 is a prime number, so we can't reduce that. 26 ninths, can't reduce that. For cross reducing, we can't reduce either one of them either. So in this case, we have to multiply the larger numbers. So 22 times 26 is 572, and 9 times 7 is 63. Okay, so now the first thing I'm going to do is change that back to a mixed fraction. So 572 divided by 63 will give me 9 as the whole number. 63 times 9, or 63 divides into 572 9 times. And then my remainder is 5. So my fraction becomes 9 and 5/63. Okay, now 5 is only divisible by 1 and 5 won't divide evenly into 63. Okay, so that's my answer, 9 and 5/63. Okay, so if you start with a mixed number and your answer is improper fraction, you must change back to a mixed number. Okay, the next one, 2/3, so we have a fraction times a whole number. So in this case, we need to change that whole number to a fraction. And the way we do that is by multiplying by 2 over 1. So 2 over 1 is the same as 2. Any number over 1 is that number. So 100 over 1, the answer is 100. 9 over 1, the answer is 9. So now we multiply. 2 times 2 is 4. 3 times 1 is 3. We have 4/3. 4/3 is an improper fraction, so we need to change that to a mixed number. 4 divided by 3 is 1, with a 1 remainder, and our denominator stays the same. So 1 1/3. So that's multiplying fractions. So dividing fractions, basically the same rules. But what we do is we change a division to a multiplication. So 6/15 divided by 3/10. We keep the first fraction the same. We change division to multiplication, and we flip the divisor, the second fraction. So 3/10 becomes 10/3. So now 6/15 times 10/3. Can we reduce anything there? Yes, we can. 6 divides by 3, and so does 15. So I have 2/5 times 10 and 3 I can't reduce, so 10/3. And then I multiply. 2 times 10 is 20. 5 times 3 is 15. So I've got 20/15. 15 goes into 20 one time, with the remainder 5. So 5/15. I can reduce that fraction, because 5 will divide by 5, and so will 15. So my answer is 1 1/3. Okay, so change to a mixed fraction and reduce if you can. Okay, next one. Again, because we've got mixed fractions, we have to change them to improper fractions first. So 2 times 4 is 8. Plus 3 is 11/4. Now, I'm not going to change that division yet, because I want to make sure that I have my improper fraction first. 1 times 3 is 3, plus 2 is 5/3. Okay, now I can flip. So now 11/4 times, so I'm changing division to multiplication, and I'm going to invert my second fraction, so it's 3/5. So I've got 11/4 times 3/5, and I'm just quick glance, I know I can't reduce anything. 11 times 3 is 33. 4 times 5 excuse me, is 20. So 33/20. That's an improper fraction. I need to change it to a mixed number. 20 divides into 33 one time evenly, with 13 remaining, and my denominator stays as 20, so 1 and 13/20, and I can't reduce 13/20 because 13 is a prime number. Okay, for dividing a whole number by a fraction, same thing we did before. That whole number needs to change to a fraction. So 4/1 divided by 2/10. Okay, now I'm going to change. My first fraction stays the same. Change division to multiplication. Flip my divisor. So instead of 2/10, we have 10 halves. And now can I reduce? 10 halves will reduce because both are divisible by 2. So 4/1 times 5/1. 5 times 4 is 20. 1 times 1 is 1, so 20/1. So my answer is actually 20. It's actually a whole number. So no fraction involved there at all. Okay, so that is how you multiply and divide fractions. Okay, so again, take your time, especially with the division, because of changing from division to multiplication and then inverting that divisor. Don't forget, that's a very important step. So you change division to multiplication and invert the divisor before you do anything else. Okay, so make sure that you're multiplying the correct numbers together. All right, so on to lesson 2. So lesson 2, we're dealing with decimals, percents, statistics, and circle graphs. Okay, so we'll learn what decimals are, percents are, and then we're going to learn about statistics and circle graphs. So today we're going to focus on decimals. Okay, so beginning on page 2, bottom of page 2 are some Math Antics videos. So if you want some more information or you want to look at something different to help you learn about decimals and fractions and statistics and everything, these are good videos to watch. Beginning on page 3 is information on what decimals are. Page 4, support question 1, and then information on changing a fraction to a decimal. And then on the next page, support question number 2. All right, so let's learn a little bit about decimals. So some decimal vocabulary to know, first of all. So a decimal is a number whose whole number part is separated from the fractional part by a decimal point. So if we look at this number here, 34.7, so this is our whole number, 34. So it's like, if you think of it in terms of money, $34. Then we have a decimal point, and then to the right of the decimal, we have another number, 7. So that 7 would be cents. So to the right of the decimal, we're looking at our cents. So that 7 would actually be 70, represent 70 cents. We don't put the 0 in there unless we're actually talking about money. But 34.7, if you think of it in terms of money, is $34.70. Okay, so 34.7. The digits to the right of the decimal point have a value less than 1 but greater than 0. So just basically like a fraction. So 34.7, we can write that as a fraction. So 34 and 7, or mixed fraction, sorry, 34 and 7/10 is the same thing as 34.7. Okay, place value. So the value of a digit, place value is the value of a digit based on its position in a number. So based on where it is in the number. So the 3 is in one place, the 4 is in a different place, the 7 is in another place. Let's erase my lines here. So here we can see the place value. So the 3 is in the tens place, so that 3 means 30. The 4 is in the ones place, so that would be 4. The 7 to the right of the decimal is in the tenths place. So like I said, that 7 means 70, like 70 cents, for example. If we have a 1 to the right of the 7, that 1 would be 1 cent. And the further to the right that you go, the smaller the value of the number. So decimals excuse me. Decimals are like fractions. They're less than 1, but they're more than 0. Okay. Digit. A digit is a symbol used to make a numeral. So it's all the numbers that we use to make the different numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each one of those is a digit. So they are the 10 digits that we use in our number system. And we can make all kinds of numbers with that. We can make 987. Excuse me. We can make 1034. We can make 6 million. Okay, so, and we're only using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But when we combine them in different ways, we make more numbers. Tenth. The 10th place shows the number of equal pieces out of 10. So like the 7 here, the decimal 7, that would be 7 out of 10. Just like a fraction, 7/10. Same idea. And then a decimal point is a dot that is used to separate the ones place from the tenths place. So right here, it's between the ones place and the tenths place. Okay, so in this example, we've got 17 with a decimal point and 48. So 17 is the whole number part. So like 17 apples are full apples, or $17. The 48 to the right of the decimal is the decimal part. So it's 4. The 4 is out of 10, so 4/10. So there's the it's divided into 10 pieces like a fraction. 4 of them are pink. The 8 is 8 out of 100. So 8, so the whole is divided into 100 pieces, and 8 of them are blue. So the 8 is actually less than the 4. So like I said, the further away you go from the decimal to the right, the smaller the value of the digit. So how to read decimals. The first method entails reading off the digits of a decimal number. For instance, a decimal number such as 0 with a decimal point, 005, is read as 0. The decimal point is just read as point. So 0.005, and 4 with a decimal point and 2 is read as 4.2. The second method is to read the decimal part number as if it were a single integer accompanied by the rightmost place value you use. So, for example, 42.37 is read as 42 and 37 hundredths. Okay, because that 7 is in the hundredths place, so 37 hundredths. And the number 8.34 is read as 8 and 34 hundredths. Okay, so if the 7 for 42.37, the 7 wasn't there, it would be read as 42 and 3/10. So to the right of the decimal place, first we have tenths, then we have hundredths, then we have thousandths, then we have 10,000ths, and it continues on like that. So depending on how far away from the decimal you get, your numbers get smaller. Okay, it's the same thing. If we go to the right, we have ones, tens, hundreds, thousands, 10,000s, 100,000s. So this case, in this side, we have thousands. To the right of the decimal, we have thousandths. So everything is a th. Tenths, hundredths, thousandths, 10,000ths. But to the left of the decimal, it's not like that. Okay, so how do we convert a decimal to a fraction? Step 1, rewrite the decimal number over 1 as a fraction where the decimal number is numerator and the denominator is 1. Step 2, multiply both the numerator and the denominator by 10 to the power of the number of digits after the decimal point. So that might be confusing, but we're going to do some examples in a minute and show you. If there is one value after the decimal, you multiply by 10. If there are two, you multiply by 100, so 1 with 2 zeros. If there are three, you multiply by 1,000, so 1 with 3 zeros, etc. Step 3, express the fraction in simplest or reduced form. Okay, so what does that mean? Okay, so step 1, rewrite the decimal as a fraction with a denominator of 1. So our decimal that we're changing, convert 0.25 to a fraction. So we're going to put 0.25 in the numerator position and 1 in the denominator position. Next, we multiply the numerator and denominator by 10 to the nth power. So how many places are there? Where n equals the number of digits after the decimal. So we've got 2 and a 5, so that's 2 digits, so we multiply by a 1 with 2 zeros, so 100. So we multiply the top by 100. We also have to multiply the bottom by 100. So 25 times 100, 0.25 times 100 is 25. 1 times 100 is 100. So 0.25 as a fraction is 25 100ths. But we're not finished because now we have to simplify. So 25 is divisible by 5 and 100 is divisible by 5. So 25 divided by 5 is 5. 100 divided by 5 is 20. But we can still reduce more. So 5 divided by 5 is 1. 20 divided by 4 is 4. So our final answer is 1/4. We can also, instead of dividing by 5 twice, I know that 100 is divisible by 25 and 25 is divisible by 25, so right away I get to 1/4. So try to find, when you're reducing, the greatest common multiple that would divide evenly into both fractions, and then you only need to divide once. Okay, second example, convert 3.125 to a fraction. So the first example, we didn't have a whole number, we just had the decimal part. This time we have a whole number with a decimal. So first of all, for now, we forget about the 3, okay, until the very end. So we're dealing with the 0.125 first. So step 1, rewrite the decimal as a fraction with a denominator of 1. So 0.125, because that 0 is holding the place for the 3. 0.125 over 1. Now we're going to multiply by what? Well, we've got 1, 2, 3, so we have to multiply by 1,000. 1 followed by 3 zeros. We have to multiply the top and the bottom by the same number. So 0.125 times 1,000 is 125. 1 times 1,000 is 1,000, so we have 125 over 1,000. Step 3, simplify. Okay, so 125, and you can do this, like I said, you can do it by dividing by 5 or by 25 or whatever, but you can also, as I mentioned, find the biggest common multiple, which, like I said, is often the top number when we're reducing. So I know that 125 will divide evenly into 1,000. So I'm just going to go 125 divided by 125, and then 1,000 will also divide evenly by 125, and that will give me 1/8, and then I have to add my whole number that I started with up here, 3, and so my answer is 3 1/8. Now you can do it by dividing by 25 first and by 5, or just dividing by 5 and 5 and 5 and 5 again. But the easiest way is to divide by the largest common multiple. So 125 divides by 125, and 1,000 divides by 125 evenly, so I get to my answer more quickly. But if that's tricky for you at this stage, then do it your way. Do it the way that works best for you. But make sure that you always simplify, because if you don't simplify, you will lose marks. Okay, so let's do some practice with converting decimals to fractions. So we'll do a couple the way we just learned, and then I'll show you a shortcut. So 0.6, so we rewrite it, 0.6 over 1. Then we are going, next is we're going to multiply. So we've got one digit to the right of the decimal, so I'm going to multiply the numerator and the denominator by 10. A 1 followed by 1 0. So the number of digits to the right, which is 1, so you add a 0 to the 1 that to multiply. So 0.6 times 10 will give me 6. 1 times 10 is 10, so 6/10 is my answer. Now I know that I can reduce this because both are divisible by 2. So 6 divided by 2 is 3, 10 divided by 2 is 5, so 3/5 is my final answer. Number 2, 0.3, so same thing, 0.3 over 1, and I'm going to multiply both numerator and denominator by 10 because I have one digit to the right. So 0.3 times 10 is 3, 1 times 10 is 10, so I've got 3/10, and I can't reduce 3/10 because 3 is a prime number. So that's my answer. 0.1, so 0.1 over 1. And again, I'm multiplying both by 10 because I only have one digit to the right of the decimal. So 0.1 times 10 is 1, 1 times 10 is 10, and I've got 1/10. And that's my answer because I've got 1 as my numerator. Okay, number 4, 1.27. So because I've got a whole number, for now I'm just going to leave that whole number. I'm just going to put it over here so I don't forget it. So now I've got 0.27, or 0.27 actually, over 1. Now I'm going to multiply by what number? Not 10, but this time I'm multiplying by 100 because there are two digits to the right of the decimal. So I've got to multiply numerator and denominator by 100. So 0.27 times 100 will give me 27. 1 times 100 will give me 100. So 27 over 100. 27 over 100, I can't reduce that because the only numbers that are divisible into 27 are 3 and 9, and they don't divide evenly into 100. So my answer is 1 and 27 over 100. Don't forget that 1 because we started out with 1.27, so our answer must have a whole number as well. Okay, number 5, 3.58. Again, I'm going to leave that 3. Let's put it over here somewhere. So 0.58, actually 0.58 over 1. And then, oops, I'm getting ahead of myself. I'm going to multiply first. So I'm going to multiply again by 100 because there are two digits to the right of the decimal, and I have to multiply numerator and denominator. So 0.58 times 100 will give me 58. 1 times 100 give me 100, so 58 100ths. Now I know that both of these are divisible by 2, so I'm going to reduce. 58 divided by 2 is 29, and 100 divided by 2 is 50, so I've got 29 50ths. Now I've got to move my 3 because it doesn't need to be there yet. Move it over here. So now I've got 29 50th, and 29 is a prime number, so I can't change that. So my answer is 3 and 29 50ths. Okay. Number 6, 0.289. So 0.289 over 1. And then I'm multiplying by how many? 1, 2, 3. So I'm multiplying by 1, 2, 3. So 1 with 3 zeros, which is 1,000. And then 0.289 times 1,000 will give me 289 over 1 times 1,000 is 1,000. So 289 over 1,000. So let me see. What can I multiply? So 289, let's see, divided by 2. No, not even. 289 divided by 3, not even. I don't think this is going to reduce. 289 divided by 5, no. Oops, I multiplied 289 divided by 5. No, so my answer is 289 1/1000ths. Okay, so that is how you do it. Now, I said I'd show you a trick, so it's a bit of a shortcut. If you understand all this, a bit of a shortcut to do is, so in number 7, we've got 0.316. Now, there are 3 decimal places to the right of the decimal. 3, 1, 6, 1, 2, 3. So instead of writing like I did in number 6, 0.289 over 1 and then multiplying by 1,000, I can just take my decimal point and move it 3 places to the right, and I end up with 316 over, and I know that that is going to be multiplied by 1,000, so I just put 316 over 1,000. So I skipped out this step of multiplying by 1,000, or basically you're doing it in your head. Because there's 3 decimal points, so you know you got to multiply by 1,000. So you just put 316 over 1,000. And then once you've done that, then you have to reduce. So 316 is divisible by 2. So I can divide top and bottom by 2. And that'll be 158 over 500. Now 158, is that divisible by 2? It is, so I can divide by 2 again. And that'll give me 79 over 250. And now 79 is a prime number, so my answer is 79 over 250. Okay, so you can skip out this step of multiplying by just counting the number of digits to the right of the decimal and then putting that over a 1 followed by that many zeros. And just kind of, if you understand what you're doing here. If you don't skip that step, okay? Okay, so you can convert a fraction to a decimal by using a calculator. So that's the easiest way. So you divide the numerator, so the number on the top, by the denominator using a calculator, and the resulting answer will be the value of the fraction expressed as a decimal. So to convert to the opposite of what we were doing a decimal to a fraction. Now to do a fraction to a decimal, we can just use a calculator. Now let's see if I can get this to work. There we go. There's our calculator. So if it's, so the example 3/8, so 3, where's my, how come it's not working? Oh, can't use it there. Okay, so 3 divided by 8 equals 0.375. So this is the easiest way to change a fraction to a decimal. So if we have the fraction, say, oh my goodness, go away. Too many ads. Okay, so if we have the fraction 10/34, then all we have to do is make 10 in our calculator, divide by 34, hit equals, and our answer right there. Okay, so that's the easy way to change from a decimal to a fraction. Now I get rid of this, and there we go. Okay, but you can also do it without a calculator. So to convert a fraction to a decimal without a calculator, we use long division. So here's an example. If you want to convert 3/8 to a decimal without a calculator, then you would have to use long division where the dividend is 3 and the divisor is 8. So how many times will 8 divide into 3, basically? So 8 into 3 won't go because 3 is smaller than 8, obviously. So we're going to bring down our first 0. So 8 divided into 30. So our decimal point is there because remember it's 8 and we're dividing into 3. So that 3 has a decimal to the right of it. So we bring down our 0, so that decimal point has to go up in our answer as well. So we can put a 0 here to hold that place. So now 8 into 30, so 3 times 8 will give me 24. So then I'm going to subtract 24 from 30, and I end up with 6. Then I have to add another 0 because 8 won't divide into 6, so that gives me 60. 8 times 7 is 56. Subtract gives me 4. Got to bring down another 0 for 40. 8 divides into 40 5 times evenly. So, and we end up with no remainder. So then our answer is 0.375. Okay, so you can do 3/8 is equal to 0.375. So you can use a calculator, which is the easiest way, or you can use long division. So there are different types of decimals. We have terminating decimals and we have repeating decimals. So 1/4 as a fraction, when we change that to a decimal, we get 0.25. So this is a terminating decimal because it stops. So if you punch that into your calculator, 1 divided by 4, you will get this come up. So that's called a terminating decimal. If you try to get, change 1/3 to a decimal, you will end up with 0.333333, and it will continue on forever. So we call that a repeating decimal because the number 3 just repeats. So in this case, we would have to round so that it stops. 3/5 is also, as a decimal, it's a terminating decimal. So 3 divided by 5 will give you 0.6. That's it, you're done. 7/9 as a decimal is 0.7777, so that's a repeating decimal because the 7 repeats. 9/11, we've got 0.818181. So this is a repeating decimal because the pattern of digits 8-1 repeats forever. Okay, so a repeating decimal is a rational number whose decimal representation has some repeating pattern, and a terminating decimal is a rational number whose decimal representation eventually stops. So for the terminating decimals, 0.25, 0.6. Some might end up with 0.3491, but it will stop. Okay, so if it's repeating, it's the same number repeated. It might be one number, it might be two numbers, it might even be three numbers. So like I said, if your answer is a repeating decimal, then you have to round. Rounding means making a number simpler by keeping its value close to what it was. So to round numbers, first count the decimal places, so the number of digits after the decimal point. So in 0.5814, 5 is in the first decimal place. It's the first one after the decimal. 8 is the second, 1 is the third, 4 is the fourth, and so on. So once you know which decimal place you're rounding to, draw a line after that decimal place. So, for example, round 0.5814 to one decimal place. So that means I would draw a line after the 5. Then I look at the digit immediately to the right, which is an 8. Since 8 is greater than 5, we add 1 to the 5, making it 6. And we drop all the rest of the numbers. So then our rounded number is 0.6. So round 0.5814 to two decimal places. So 1, 2, I draw a line here. Then look at the digit again to the right, which is a 1. Since 1 is less than 5, we leave the 8 alone and we drop the rest of the digits. So that means that 0.58 is what we round to when we're rounding to two decimal places. So if the digit to the right of the line is 5 or higher, increase the digit to the left by 1. If the digit to the right of the line is 4 or less, keep the digit to the left the same and remove all the other digits. Okay? All right. Whoops. Let's have a look at key question 10. So key question 10, write the following as fractions. So you're changing the decimals to the fractions. And then in number 2, you are changing fractions to decimals. Okay, so that's key question 10. So try to get that one done before our next class on Tuesday. And then on Tuesday, we'll pick up where we left off. Okay, so Please contact me if you have any questions. Otherwise, enjoy the rest of your day and have a great week. Miigwech.